Okay, so the first question is asking us to divide using mental math. Now, if you don't want to use mental math, that's fine. I actually kind of like doing these, you know, by writing it out. Divide using mental math. 2.70 divided by 10. So 2.70 divide by 10. That means the number is getting smaller. And because we're dividing by a um, multiple, not a multiple of 10, a power of 10, that means we move the decimal over one space, which would be right there. That's an ugly arrow. So this would be 0.270 or 0.270 or 27 hundredths. Either one of these is an acceptable answer. So for number 2, we are dividing 3.35 by 10 to the second power. That's the same as 3.35 divided by 10 squared is 10 times 10 is 100. Well, once again, we're getting smaller because we're dividing by 3 divided by 100 is obviously going to get smaller. Uh, and it's a power of 10. Well, it's actually 10 times 10, which is 100, which means I would move the decimal not one spot over, but 2, which means I would have to fill in this blank spot with a 0. So, excuse me, this should have been a 5. 0.0335. So there's my answer. 0.0335. I kind of messed up that explanation a little bit, so why don't I do it this way? If I have 3.35 divided by 10 squared, which is 100, means I would have to divide by 10 times another 10, which means the decimal would go there. So once again, 0.0335. Number 3. Number 3. Divide using mental math 2,201.8 divided by 10 to the third. This is the same as 2,201.8 divided by 10 times 10 is 100 times 10 is 1,000, which dividing by 1,000 means I'm getting smaller, and I'm moving the decimal over 1, 2, 3 spaces. So the correct answer is 2.2018. There's my answer. Number 4, the correct match each expression with its quotient. So 821.22 divided by 10, that means the decimal would move one spot over. So it would go there. So that's 82.122. That means this one matches here. This one divided by 1,000. 821.22 divided by 1,000. That means 1, 2, 3 decimal places. Right? 1, 2, 3 decimal places. So the decimal will go there. So 0.8122. So that one matches here. And the last one, before I just choose it, let's just make sure. 821.22 divided by 100 means the decimal would move over 1, 2 spaces. So it would be between the 8 and the 2 here. So 8.2122. There you go. Number 5. Ooh, I meant to block that off. Which expression shows the best compatible numbers to use to approximate the quotient of? Quotient is the answer of a division. So the quotient of 7,805 divided by 85. Now, I keep saying in class compatible numbers are numbers that work well together. So I decided to actually look in the textbook to find the actual definition of compatible numbers. Now, I say numbers that work well together, they say this. Let's see if I can kind of highlight it so that it, yep. They say the definition of compatible numbers is numbers that are easy to compute with mentally. Let me rephrase that. Numbers that are easy to compute with mentally. So, what looks like compatible numbers here? Now, all of these numbers are kind of close to 7,805, right? All these numbers in the first column. And all of them are kind of close to 85. There's 80, 90, 80, 90. Okay, so we really are looking for numbers that are easy to work with mentally. Well, if you look at this, this is kind of like begins with an 80 divided by 80. Well, that's going to be easy to work with. So that's a maybe. How about 80 divided by 90? That's not easy to work with mentally. How about 75 divided by 80? That's not easy to work with mentally. And 75 divided by 90, that's not easy to work with mentally. So the answer that is the best answer for compatibility, oops, is A. Didn't mean to use the magic pen for that. I'm going to use a regular pen. There you go. There's the most compatible. There's the answer with the best compatible numbers. All right. Mr. Lipkovsky won the lottery. He decided to give his seven favorite students $8.96 to split evenly. How much money will each student receive? Well, I'm basically dividing 8.96, $8.96 into 7 equal groups. All right, let's change colors here just so that we can keep track of the original. 7 goes into 8 one time. 1 times 7 is 7. So my remainder is 1. I now bring down my 9. 7 goes into 19. Well, 2 times, because 3 times would be too much. 7 times 2 is 14. My remainder is 5. And now I bring down my 6. 7 goes into 56. How many times? Well, 7 times 7 is 49. That's not enough. 7 times 8, that's it. 8 times 7 is 56. My remainder now is 0. So how much money would we split? Or my 7 favorite students? Each of the students would get $1.28. Number 7. Mr. Lipkovsky won the lottery again. This time he decided to split his winnings among the 5 students with the best dance moves. Interesting choice. Mr. Lipkovsky has magical powers where he can split money beyond the 100th decimal place. It's good to know. If he won a total of $1.09, that is now $1.09, that's a big lottery winning. Exactly how much will each dance student receive, or dancing student receive? Well, I have $1.09, 1.09, and I'm going to divide it into 5 equal groups. Well, does 5 go into 1? It does not go into 1. So normally, if it's the only number in front of the decimal in the ones place, if that's the only digit that I need to put up here is a 0, you want to put it up there so you can see. Sometimes I kind of go, does it go into 1? Does it go into 10? But here I should put the 0 there. Now, how many times does 5 go into 10? That's 2 times. 2 times 5 is 10. Remainder is 0. So I bring down my 9. How many times 5 go into 9? Well, it goes in 1 time. 1 times 5 is 5. My remainder is 4. I really kind of should have changed colors, but I'll do it now. Well, I have to go to the next decimal place to continue here. So it's how many times does 5 go into 40, right? I added that 0 at the end. 5 goes into 40. How many times? That would be 8 times. 8 times 5 is 40. I now have no more remainders, so this is $0.218, or 21.8 cents, right? Remember I said that I have a magical power where I can split money beyond the hundredths place. Hope that helped. Circle yes or no to tell whether the number 100 will make each equation true. So I'm going to do these one at a time, and then we will circle yes or no. So 250 divided by 100. Well, dividing by 100 means the decimal goes over 1, 2 spaces, so that's equal to 2.50, which is 2.5, so this one, yes, it does work. 60 divided by 100. Once again, I have to move the decimal 2 spaces, so that's 1, 2. That's 0.60, but remember, if you don't have anything in the ones place, you want to really put the 0 out in the ones place. So that's 0.60 or 0.6, which is 6 tenths is the same as 60 hundredths. So this one also works. Let's go to the next one in purple. 0.3, divide that by 100. Well, dividing by 100 means I have to move the decimal place 2 slots. So 1, 2. That means I have to add a 0 there. So I'm actually going to, instead of writing it just out here, I'm going to write underneath here. Fill in that 0, that empty slot with a 0. 0, 3. So we put a 0 out in front of that. And we get 0.003. We took this decimal and moved it 1, 2 spaces. So 0.003, well, that's not the same as 0.03, right? This is 1, 2 zeros and then a 3. This is 1 0 after the decimal, then a 3. So this is a no for this one. And the last one, do that one in green, is 0.52 divided by 100. Well, this one also, you got to move the decimal 1, 2 spaces over, and you end up with 0.0052, which is exactly what it says up there. So 0.0052 matches up here, so that is another yes. Moving on to number 9. 5 goes into 14.95 how many times? Well, I like to put the decimal right there. Does 5 go into 1? No. Does 5 go into 14? It sure does. 2 times 5 is 15. What am I talking about? 2 times 5 is 10. So remainder is 4. I bring down the 9. 5 goes into 49. Well, it goes in 9 times because 9 times 5 is 45. So my remainder once again is 4. And I bring down the next 5. 5 goes into 45 9 times. 9 times 5 is 45. We have no more remainder, so the answer is 2.99. Number 10. How many times does 16 go into 38.72? Well, does 16 go into 3? It does not. How about 16? Oh, I'm sorry. I always get lazy and write. You should really write decimal place right there. 16 doesn't go into 3, but it goes into 38 2 times, because 2 times 16 is 32. Remainder is 6. So now I bring down my 7. Well, how many times does 16 go into 67? Well, 16 goes into 67, let's see, 4 times, because 4 times 16 is 64. 4 times 16, 64. My remainder is 3. I now bring down a 2. 16 goes into 32. How many times? Exactly 2 times. 2 times 16 is 32. I subtract. I have no more remainder. Let's go to number 11. All right, 24 going into 22.68. Put our decimal point right there. Does 24 go into 2? No. Does 24 go into 22? No. So I'm going to put a 0 there. Does 24 go into 226? Well, yes, it will go into it. And honestly, I'm looking at this. 10 times 24 is 240, and this is pretty close. 226 is pretty close to 240. So I'm going to try one less than that. So 9 times 24. 9 times, oh, sorry, this is where I use my scrap work to, to calculate my numbers that would go here in my neat work. 9 times 4 is 36, carry the 3. 9 times 2 is 18, plus 3 is 21. So, yeah, 9 times 24 is 216. So what's my remainder? My remainder is, subtracting, remainder is 10. So now I bring down my 8. Well, how many times does 24 go into 108? Well, let's see, 24 times 4, well, 25 times 4 is like 100, so this is close to 100. Yeah, let me try 4 here. All right, actually, I should have tried it over here first. 4 times 24 is 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Plus 1 is 9. Yeah, 96. It's close to 108. If I added another 24 to that, it's going to be 6 plus 4 is 10. 1 plus 9 is 10, plus 2 is 12. Yeah, 120 is too much, right? So, yeah, it's not 5 times, it's 4 times, right? So 4 times 24 is 96. If I went too fast, go back and look there. I'm basically deciding why 5 times 24 is too much. So 8 minus 6 is 2, and this is 0. This becomes 10 if you prefer to do it this way. 10 minus 9 is 1. So I have 12 remaining. Well, we're going to continue. There's another 0 out there that we can put zeros forever at the end of 22.68, right? Oh, and we already kind of just figured out that 5 times 24 is 120. I just did that over here. I kind of blocked it off. So yeah, 5 goes in this decimal place right there. 5 times 24 is 120. I now have no remainder. So the answer to this one is 0.945. And now for our last problem, number 12. How many times does 19 go into a 1? It doesn't. 19 into 12? It doesn't. How about 19 into 124? All right, so I'm going to do a little estimation here. 19 is close to 20, and this is close to 120. So 20 times 6 is 120. So I'm going to try 19 times 6. Ready? 19 times 6. 9 times 6, 54. Carry the 5. 6 times 1 is 6, plus 5 is 11. Yeah, it's 114. That's pretty close to 124. All right. If I added another 19 to that, it would be too much. So yeah, right here, I'm going to put a 6. 6 times 19 is 114. My remainder is 10, right? And I bring down a 3. Well, I know that 6 times 19 is 114. That's too much, so I'm going to try one less than that. So 5 times 19, 5 times 9 is 45. Carry the 4. 5 times 1 is 5, plus 4 is 9. So that would be, yeah, 95. So that's pretty close right there. So I'm going to put a 5 here. 5 times 19 is 95, which means my remainder, 103 minus 95, is 8. Now I'm going to bring down this 5 right there. Well, I know that 19 goes into 95 5 times. That's too much. I have 85 here. So I'm going to do 4. 4 times 19. 4 times 9 is 36. Carry the 3. 4 times 1 is 4, plus 3 is 7. So, yes, 76. So 4 times 19 is 76. My remainder is 9. So I got another decimal place coming to me. Oh, right there, 95. We already know that from this step right here, that 5 times 19 is 95. That means there's a 5 right there. 5 times 19 is 95. My remainder is 0. And there's my answer. It's 6.545. Hope this helped.